All right, thanks for buying the Properties of Exponents flipbook. I want to show you how to fold it. So I printed this on normal letter size paper, and following my printer's instructions, I scaled it to fit so the whole image fits on the page. If you run into any issues with the pages not like getting cut off, it's probably your printer settings that I would double check. But I printed it front and back, just normal. And then I think the default is the long side, however it normally defaults. Anywho, it's gonna come to you like this. And what you do is spread apart these pages so that you can see all three of the pages. And so we're gonna have first flap is the title, and then I'll say 0 exponents, and then I'll say negative exponents. And these lines are meant to be a guide along with the ones in here. They won't probably line up perfectly. It just depends, like I said, on the user folding and all of that. So, man, this is a lot of pressure doing that. So what I'm gonna do is flip it over and fold down like so. So that reads Properties of Exponents here. Open it up, I'll be able to write in here. Negative exponents, product of powers, quotients of powers, power to the power. And then product of powers. And what I do is make sure it stays secure. So it doesn't fall apart like mine just did. I have my stapler, and I just staple it to the top here in 2 spots, like so. Now you have your flip book of exponents, and I have a cute little flip book for you. I'm so excited. So my, of course, isn't going to show the flippability part of the book, but I'll have a little video probably about how to fold this if you buy the flip book and you're curious. So, properties of exponents, you may also hear them called laws of exponents. All right, so first things first, we're gonna go through this line by line. We are on the 0 exponents channel. For any non-zero number A raised to the 0th, yes, that's a real word, power is 1. So A to the 0 is 1. So they asked you to simplify 4 to the 0th power. Just get out 1. Fairly straightforward there. Next flap is on negative exponents. For any integer n and any non-zero, a raised to the negative of n is equal to the reciprocal of the base to the power of n. All right, so what this looks like is a to the negative n is equal to 1 over a sub n. So let's see what this looks like. If I have 2 to the negative third, that's going to be the same as 1 over 2 to the positive third. I'll go ahead and just do that one for you. That's going to be 1/8. All right, next we have two properties that kind of go together. So product of powers, so things with exponents, finding the product, that's going to be multiplication. Right, so maybe right over here, this one is multiply. You're multiplying your bases, and here you're dividing your bases, the quotient of powers. All right, so let's look first at multiplying. So to multiply powers with the same base. So by powers, I mean things like with an exponent, not the exponent itself. So what you're going to do is add their exponents. So a to the n times a to the m is going to be equal to a to the n plus mth power. So it's always like whatever's going on with the bases, it's one less sophisticated operation in the exponents. So here we've got 3 squared times 3 to the first. Well, that's going to be the same as 2 plus 1, which is 3 cubed, or 27. All right, to divide powers, right, things that a base with an exponent, that's what I mean when I say powers, the same base are going to subtract their exponents. So if I have a to the nth over a to the nth, that's going to be equal to a to the n minus m, like so. And the reason here, if you wanted to sit around and prove these, is think back to negative exponents. If I wanted a to the m to then be in the numerator, I could rewrite it using a negative exponent and then use the product of powers property. But of course, that's a lot of proof you may not be interested in. All right, so if I were to simplify here, 2 to the 4th over 2 squared, this is going to be the same thing as 2 to the 4 minus 2, or 2 squared, which is 4. All right, next we are going to look at a power, okay, which is what I'm talking about when I say, if you think about like addition, multiplication, and then like a base to some power as 3 kind of levels of operations. Whatever's going on with my bases, my exponents are always doing one lower. So like if my bases are being multiplied, then my exponents are being added. But here what's going on is I'm going to have a base raised to some power, and so I'm going to end up doing one step lower on the levels, and I'm going to multiply my exponents, not to give it away. So if a is a real number, and m and n are integers, then to find it power to the power, we're going to multiply the exponents. And so we'll have a to the m raised to the nth. So this will look like a to the m times n power. So what this would look like in real life with actual numbers, I've got 6 squared, and that's being cubed. So this is going to look like 6 to the 2 times 3 power, which is 6 to the 6th power. And this is the last crazy exponent I'll do, and I'll start leaving them written with as a base to an exponent. But it would be 46,656. All right, and last but not least, we've got 2, again, that kind of work together. Power of a product and power of a quotient. So what's happening here, when you think about the order of the words, is power of a product means that I have some multiplication going on, and that's getting raised to an exponent. And power of a quotient means that I have some sort of dividing that's going on. I'm going to raise that to an exponent. All right, so to find the power of a product, right, a product multiplication problem, we're going to find the powers of each factor, and then you will multiply. So a times b to the mth power is going to be the same as a to the mth times b to the mth power. All right, so if I were to simplify here, this would look like 2 to the 5th times 3 to the 5th. And again, I'm not doing that for you. I was just showing you the property. All right, so for the quotient side, to find the power of a quotient, which is just a fancy way of saying a division problem, we're going to find the power of the numerator and the denominator, so top and bottom, and then carry out the division. So a over b, right, to the nth power is going to be the same as a to the nth divided by b to the nth. And so if I do this problem here, that would look like 3 to the 4th over 5 to the 4th. Those are equivalent statements. All right, so I hope you enjoyed this, whether you're looking at properties or laws of exponents for the very first time, or doing a little review, and I'll see you later.